do you see the rate of change in the graph on the right, the red graph? How do you see that? Or how's it represented, the rate of change in the red graph on the right? What's that? It's additive. Melissa, what do you think? How is the rate of change represented in the graph on the right, linear function? Okay. Rise or run. Okay. Constant rate of change is seen in the slope, right? It's seen in the slope. Okay. So we want to. There's a different way to represent rate of change other than we see it in the slope of a linear function. We can also represent it by actually putting rate of change as the y quantity. Okay. So we have the same x scale, but rather than graphing the quantity that has constant rate of change and seeing that in the slope, now we'll have the y, the output, be the rate of change. Okay? So, so for a delta x interval, so no matter what delta x interval you pick, you see that, okay, you get the same constant rate over every interval. So it's a different way of showing what we've seen so far, seeing that that constant rate is seen in the relative size of changes in y to changes in x. So the right is where we've been so far, seeing that constant rate of change as the size of delta y relative to delta x. Now we're introducing something new, a graph where we actually, as the y output, we actually graph the rate of change. And if it's constant, which it is on the right, then how does that show up? So unchanging rate means that y value stays the same and we get a horizontal line. Okay, so here's one of these rate of change functions, and so we're going to call these R for rate of change, and then this subscript is telling you which function it is the rate of change for. Okay, so here's a rate of change function. When x is less than 0, the rate of change is -1, and when x is greater than or equal to 0, the rate of change is 1. So what I want you to do is, can you recreate the graph f that has this as its rate of change function? Okay, so go ahead and do it. Can you recreate the graph f that has this as its rate of change function? Go for it.
Okay. So this y is rate of change. This
yep,
y?
This is a rate of change function. So whenever we have an little r function, that's from here on out, it's going to mean a rate of change function. So it's the rate of change for the function f. So can you represent the function f that has this as its rate of change? So show me. I want to see what you're thinking.
So we create something that you had like on the left side. In the previous slide.
Yeah, I had a rate of change function on the left, and then the corresponding quantity function on the right. Okay. So now I'm asking you to come up with a function that has this rate of change.
Yeah, so that's
So, graphing calculator is optional. So if you want to sketch on a piece of paper, that's fine too. So graph calculator is optional.
Or did you press shift?
Okay, so we'll keep that in mind. We'll talk about that. Okay. Yeah, Jocelyn.
I can't do this in terms of effects. If I do that.
Did you do control 9 or shift 9? Just 9. It's got to be control 9. If you're setting up a function, it has to be control 9.
Yeah.
You got to do control 9.
No.
Okay. So what does a rate of change of -1 mean? What's the meaning of that value? Rate of change of -1. Christopher.
Well, for me, the way that I see it is that the way that how that was defined was set up very similar to how the absolute value is defined.
Okay.
And the way the absolute value is defined is how the blue function on the right is.
Okay.
So the way I saw it as is that it was just like you take a value for y, for instance, and you say it's this value if x is less than 0, and then it's a negative value if x is less than 0, and it's a positive value when x is greater than 0. And in the same sense, it's the same way how you would graph absolute value.
Okay. So same question, Crystal. What does it mean that the rate of change is -1?
That
Has a -1 slope.
Okay, -1 slope. Richard.
For any given change in x,
Okay.
we will have a decrease in y for that same quantity.
Yeah, so it's a relative size. Relative size on -1 is the relative size of a change in y relative to change in x. So whatever change in x you make, you're going to have the same change in y, but the opposite of, right? The opposite of that change in x as the change in y. Okay, so James, you had a comment about the function that has this as its rate of change function.
Well, there's an infinite number of functions that create a negative slope, or -1 slope for x less than 0.
Agree with that? Can you think of another one that has this rate of change function? Chrissy?
Negative x plus 1 and x plus 1 will have the same rate of change.
Okay.
So anything around basically wherever we move it on the y-axis.
So you could translate that out. What about this?
Well, I didn't even think about that much.
Does that work? Does that have this as its rate of change? So even more than an infinite amount.
More than our thinking.
Right. So yeah. So it doesn't even have to be continuous, right? It doesn't even have to be continuous. Okay. So this is the idea of graphing rate of change. Graphing rate of change. We've looked at constant rate of change. So whenever we see these graphs of rate of change, for the interval of x, we'll see a horizontal line at the value of the rate of change corresponding. Yeah, Jocelyn.
Is there a way in graphing calculator that we write like the r and then do the sub and the f of x that it'll do it like that? Or is
Someone had that in their. Someone showed me. Who was that? Is that Mark? Did you have sub?
What does it say?
Someone was doing. I've never used that. I've never done that.
Oh.
What is it?
I've seen it done.
It's Control L.
Control L.
Oh, for subscript?
Yeah.
Yeah. Yeah.
Control L. There you go.
For PC.
Cool. And
Yeah.
Mac.
Mac is the same. Okay.
I just want to make sure.
Okay. So let's look at a real world example here. So this is a tax table. Okay. How does the tax table work? How do you use this? Anyone do their own taxes?
Well, I'm
Not
like,
using the table.
computer.
No, yeah. I mean, you don't hire someone to do it. Okay. So if you only have 1 or 2 jobs and not a lot of investments, or it's very easy. Especially if you're single, it's very easy to find your tax in the tax table. So, for instance, if you make $26,240 and you're single, How much tax do you owe?
Between 3 and 45.
It's not between, it's a certain amount. How much tax do you owe? Brianna?
$3,485.
$3,485. You guys agree with that?
Oh wait, no, that's wrong.
No.
I don't know the exact number.
Is there an exact number or not?
3,523.
3515.
3515. So let's take a look. So what we're saying is, so here's how it works. When you're at least this value, less than this one. So in between these two, when you're in between those two values, you get your tax. So where are we at? Are we here?
Second column, I'm talking
Yeah,
Oh, no,
240.
240. So here we go, sorry. So someone who said 3515 for a single person, that's right. Okay, the question is, where does this table come from? Besides Washington, D.C. Mathematically, where do the values computing your tax come from? Mathematically, anybody know? Ashley?
Well, isn't it like there's different brackets for how much you make? Like if
Okay.
you make under a certain amount, you're taxed at a certain percent, and then if you're like in the next higher bracket, you're taxed at a different
So it's like a
percent.
piecewise function where the slope is different between each
Yeah.
Okay,
x equals or less than greater than.
that's right. We have what's called a progressive tax rate in our country, progressive tax rate. And so let's take a look at that. It means we break up the taxable income into different brackets, and we see different tax rates in different brackets.
Yeah.
Okay, so here is a function, and it's called tax rate of x. So let's first establish input and output of this function. So input x is the input into this function. What quantity does x represent? Right.
Taxable.
Yeah, so it's your taxable income. So after you got all your take-home pay, and then you got deductions and stuff, and then you have a certain amount of all your income that is taxable. So it's your taxable income. Okay, and then what does this function? So you put in taxable income, 75,000, and this function spits out a value. What is the quantity that it gives you? Mario,
How much tax is getting taken out?
how much tax is getting taken out?
So you
Like a dollar amount? Tells you the dollar amount?
Yes.
no.
Oh. Oh.
But there it is. Where your x falls in the piecewise.
The percentage of your income.
What's that?
Is it the percentage of your income?
The percentage of your income that's taxed.
Well, it's not 0.25.
Okay. So if someone who makes $75,000 in a year, they're going to look in which line? This line here?
The third line.
Yeah.
Yes.
And the output will be 0.25 for an input of 75,000. What's that? The output of the function is 0.25. If you put 75,000 into this function, it spits back 0.25. So does it mean that
Okay.
the person is going to pay 25% of 75,000 in taxes? Eric saying no.
Well, that just, I'm not sure, I was gonna say something about the rate, but so we're talking about tax rate, if you put that in, that's where you fall, wouldn't that just be something you multiply by?
Oh, this is the other graph. The rate graph where the y
What does the
Tax is the rate.
0.25 mean? The output if the input's 75,000. So let's think about a year. So let's say someone makes 100,000, okay, in a year. we can think about that as their taxable income growing throughout the year. So when the year started, how much was their taxable income? 0. Then sometime along the way here, they reached a taxable income of 8,370. Then later in the year, maybe March, April, May, something like that, they reach 34,000 in taxable income. Then toward the end of the year, November, October, they hit 82,400. So in January, they start making their first dollars, and their taxable income starts to grow. At what rate are they taxed for those dollars? 10%. Okay. Then they reach the point where their taxable income is 8,370. Then the next dollar, the 8,370, first dollar that they make, what tax rate do they pay on that? 15%. And then similarly, after the dollars they make after 34,000 are taxed at 25. And then the dollars they make after making 82,400 are taxed at 28%. Question?
I thought that if you made less than like $500 of taxable income, you weren't charged taxes at all.
She's pushing your 0. It should be
Or
500
there might be
to.
a state variance or something. Okay.
Yeah, so it would just be a different schedule. So there would be a different schedule for if you make only so much income, you don't pay tax at all, and that's true. But still, the 10% for the first 8,000. So the first dollar that a person making $100,000 gets taxed at 10%. Does that? So we still need that 10% bracket because anyone who makes greater amounts, they're gonna all their first 8,370 are going to be taxed at 10%. Okay. So, are these rates? Are these rates of change? These values, 0.1, 0.15, 0.25, are they rates of change? And how are they rates of change? How can they be thought of as rates of change? They're the rates of change of what with respect to what?
Income with respect
It's the rate of change of amount of taxable income with respect to dollar amount of tax owed.
Okay, so he's saying it's the rate of change of taxable income with respect to dollar amount of tax owed.
It's the other way around. It's the
Or
amount
unless
of
the other way around.
taxes, because your output would have to be taxes that you would pay.
So if we think about rates as relative size,
The rise is.
If we think of rates as relative size, which one is in the numerator? Is our tax due 0.25 always of our income, or is our income 0.25 of tax due? What's that?
Divide by fraction.
So which one is it?
It's a change in income.
So we got two quantities, taxable income and tax due. Those are the two quantities, taxable due. Huh. And tax due. So if these are rates of change, they're rates of change of which of those quantities with respect to the other one. So how do we set up the rate of change? What is 0.25? Is it a rate of change of income with respect to tax due or tax due with respect to income? Yeah, Andrew.
Respect your income.
Why?
Because depending on what your income is, determines the rate in which your taxes are being taken.
Right.
So income's the input.
Which is a greater value? Or which is the lesser value? Because we've got a rate less than 1, right? So which is the lesser value? Tax due, right? Tax due is 0.25 of taxable income.
Per,
So these are rates of change of tax due with respect to taxable income. Okay, and so then these values are the breakpoints in the rates. 8,370, 34,000, 82,400, etc. This is where the rate abruptly changes. So you're making 15. You're paying 15% on the 8,369. I'm sorry, 33,000. 30. What is it? 33999. 33999. Now that dollar you pay 15%. On the next dollar you pay 25%. Okay. What's that?
Actually, no, not based on what you have there.
Did I say it wrong? So
yeah.
on the 34,000th dollar,
Yeah.
you still pay 15%.
Yeah, and then.
34,001,
Yeah.
you're right.
Exactly.
You pay 25. Yep, you're right. You're right. Okay. So here's another function. Take a look at this one. What's the input and output of this one? What's the input into this function called tax?
Input is taxable.
Mario, what do you think?
Is it still taxable income?
Taxable income. Agree?
Yeah.
Output?
Tax due. Total tax.
Output is tax due. The last function, the output was?
The rate.
Yeah, but it was only, which rate was it? It's the rate of the
Yeah,
last
like
dollar
rate
that
per-
you
rate
make,
per-
right?
rate per-
It was the rate of the last dollar that you make, not the rate you paid all your dollars, just like the last dollar and all the dollars in that bracket. Okay? Okay, so in what way does our tax system force us to, and y equals mx, so what is our, let's start with this. What is our point slope formula of a line? Point slope formula of a line. What was that? Y equals mx plus b. Is that what we said?
That's the y-intercept.
Point slope form.
Point slope is y minus y1 equals m times x minus x.
What was the point slope form that we
Y
L of
developed in our
AB.
class?
Oh, one.
L of
That's
AB
that.
equals
One minus
m
two.
times x minus a plus b.
Oh, yeah. L-
Remember our class?
L of x equals m x minus a plus b.
So how does the way taxes are constructed and this formula force us to write the tax code this way, or the output of tax due? So the tax due function, how is it the way that taxes are constructed? And the nature of this function right here, the nature of this form right here, are we forced to write the tax function in this way? James, it sounds like you look like you're going to have an answer to that.
I didn't actually understand the question.
So, how is it that the tax system is set up? And then this function right here, how are we forced to write? Why are we forced to write the tax function this way?
Because we have to write the present.
Okay.
Because the income you make at each point is dependent. Yeah, I don't really know how to say it.
Okay, that's fine. That's right.
It's because like what you're saying, like for a certain amount of money that you make, you're getting taxed that amount, but once you get past it, you're getting taxed a different rate because you're making that more money than that tax bracket.
That's right.
Had you planned on.
So how does this relate to what you're saying? How does the m times x minus a plus b? How does that relate to what you're saying?
Do you want us to say
M is the slope and the point, which is your rate of change, or your change. So your 0.15 is how much it changes.
Okay.
And then the A would be the beginning of that piece of the graph that you're in, plus the output of that beginning.
So do you see M times X minus A plus B here?
Yeah.
You see it? You see that?
Yeah.
So let's break it down. So again, what's the output? All right, let's look at this one, this piece of it right here. So first of all, how about the X minus 3,400? What does that quantity represent? Sorry, 34,000. This is a quantity. This is a number. What does that number represent?
The amount of money you made in the interview. It's the amount of money that you made in the.
Right.
The number of dollars they made for that tax bracket.
The number of dollars they made in that tax bracket.
In the interval. Yeah.
So it's the number of
And
dollars
that
they
should be
made,
taxed, the number of dollars that should be taxed at that tax rate.
which is which rate?
25.
Okay, so it's the number of dollars that are taxed at 0.25. Is that what that is? Or the number of dollars that you make, what? After 34,000. Okay, so it's the number of dollars you make after 34,000, which are taxed at this rate, 0.25. Okay, so then what is, multiply that by 0.25, what's that? So new question, what's 0.25 times X minus 34,000? Somebody new? How about Brianna Horn? So 0.25 times, so I'm asking about this quantity right here. What does that quantity represent?
That quantity represents rate of change.
Amanda, what do you think? You agree with that? She said the rate of change.
That's what I think. It's because if you look at the slope formula, it's M and then you have X minus A.
Okay.
And we know normally that means slope. So at that point, that's what kind of the piecewise, that's what the slope would be at that moment.
Okay, so they're saying rate of change or slope is what that quantity is. Teralina, you agree with that? .25 is the tax that's due. Chrissy.
That whole thing is the extra taxes that are due after you've already done, taxes before. So basically, if you, actually, there was no number before 3,400, or 34,000,
Okay.
then that would be how much taxes you should be paying.
So you're saying it's an amount of tax. Alexis, what do you think?
I think that it's a fourth of the money in that interval that you're being taxed on. So the X minus 34,000, whatever that was, it's 25% of that.
Okay, and what quantity would that be? 25% of the money we've made after 34,000. What does that represent? The tax due on? On all your taxable income.
No,
Andrea?
The amount of your taxes due for your income after $34,000 before 82. So for that tax bracket, for that income bracket, it's the amount of taxes you would pay on those dollars in that bracket.
Okay, you hear that? Yeah, that's what it is. We've got the amount of money we've earned in that bracket. We multiply it by the rate, we get the tax due on the money that we've earned in that bracket, the money that we've earned in the 25% bracket. Okay, why do we add the tax of 34,000? What's that about?
All the taxes you paid so far.
All the taxes you paid so far.
That's accumulation.
But they're due so far.
So then the whole box then represents what? The thing I put a box around. We've got this quantity, and we got that quantity. What does it mean to sum those up? Michael. Somebody new. Melissa.
How much tax do you have to pay so far? Like, so if you've only had $34,000, you only made that much.
Okay.
And just all your taxes accumulated together. Like taking the first bracket and the second bracket. It just, I don't know how to explain this well enough. It's just all the tax due that you have so far and what you counted and the money you've made.
Yeah, right.
When your income, at the point your income was 34,000, you fell into this interval and you were taxed this much, and that is the result of you would have 34,000 minus that times the same thing happening 83,000 times that X. It recurses back to
So what's the
previous
quantity
intervals.
in the box? The quantity in the box is what number? It's a value in the box. What value is it?
It's your tax due after making more than 34,000 less than 82,400.
It's almost a constant.
Okay. And is it just a part of your tax due or all of your tax due?
All.
It's all the tax you owe
Oh, that whole box.
on the first X dollars that you make when that X is in this bracket, in the 25% bracket. It's all the tax that you owe. So just getting a feel for understanding this table, how it works. Okay, so quickly, can you find the tax on $50,000? So find how much tax you would owe on $50,000 as fast as you can, so we can move on.
Sweet, that should be an absolute value. Should be 824 minus 6,000. Oh, I'm there. Okay, yes, I got it.
So which line are we going to go to for 50,000? So which line? This one? Yep, we put 50,000 in, and so how much do we make that's taxed at 25%? $16,000. Okay, it's taxed at 25%. But then we have to add all the tax we made in the previous brackets. The tax on 34,000, which is, what do we do with that? So tax of 34,000 means take 34,000 and put it in there. And where does that send us? Second line. So how much of our dollars were taxed at 0.15? 0.15 times 34,000 minus 8375 plus what?
Plus, you have to go back to the first one.
This says put 8375 in here, which is going to shoot us back out here. So plus, is that $837.50? Does it make sense?
Yes.
So we're get a certain amount of tax that would be the total tax due on an income of 50,000.
Yeah, 694? Well, 695?
How much total?
6,095?
6,095. Okay. So this idea of owing tax can definitely be thought of a static thing. The end of the year comes, you look at your taxable income, you go to the table, you get a amount that's due. Okay, but we want to think about taxes as accumulating throughout the year. Okay. So I have a series. So what I'm showing you here is This is the tax rate function, and this is the tax function. So to get oriented to these graphs, I've got a series of questions, and the first is, where in this animation should you look to see, so this is Sarah someone named Sarah, it's taxable income growing. Where in the animation should you look to see her income growing? Jason? It's right there. Where in this animation should you look to see Sarah's taxable income growing? Okay, make sure you're tracking with us. Eric?
On the right.
On what? Be more specific. Where on the right? There's lots going on the right.
Okay, well, when you say Sarah's taxable income is growing,
yeah.
You can see on the right that you see the income that she's making, and then every time she changes is how much more money she's making within that period, so you can see the slope change.
Should we be looking at the slope to see her taxable income growing? Mario?
We should be looking at where a point is, we look at where it is on the Y. So as it's growing, the Y shows how much is due. Oh, but wait,
Where in this
sorry,
animation should you look to see Sarah's taxable income growing? Ashley?
On the x-axis of both graphs, it shows that line that's moving across. Is on the bottom, the thick line is showing her taxable income increasing.
That's it, right? It's the x-coordinate. Taxable income is our input to both these functions. So that thick black line, as that grows, it's mapping out the taxable income. Okay? So where in this animation should you look to see Sarah's marginal tax rate for the current value of her taxable income? Where should you look to see her marginal tax rate? Sarah?
On the left graph, and you want to look at both the x and y axis because depending on where money she's making, you have to look at the y-axis to see what tax rate she's going to use.
So the rate is the y-axis. So you're going to look at the y-axis on the left graph. All right? Where in this animation should you look to see the amount of tax Sarah owes for the current value of her taxable income? Morgan?
The y-axis on the right line.
She wants the y-axis on the right graph. Okay? What does that mean, the current value of her taxable income, when that amount is continually changing? Do you agree that the current value of her taxable income is continually changing? So
Yes.
what does the current value of her taxable income mean? If it's continually changing, what does that mean?
It's not a constant.
But what does the current value mean? How do we make sense of that? Missy? You guys have got to pay attention, okay? So this isn't time to work on something else, okay? So what does the current value of her taxable income mean in this animation? And that amount currently continually changing. Any ideas? Here's a hint. What's that? What does the current value mean?
At a certain time, like during the year, I guess, like during the year that she's working, the amount of money that she's made up until that point.
Yeah, so in order to talk about a current value, when it's continually changing, it's kind of like we have to pause time. We have to pause time, and then wherever we pause time, that's the current value. And then a little more time goes by, and we have a new current value, right?
You order pairs. You have order pairs.
That's right. Okay, what does a point on the right-hand graph represent? So this graph over here. What does a point represent on the right-hand graph? Jocelyn.
How much her taxable income was, and then how much tax she owes.
Okay, so did you hear say two pieces of information? Yeah, a point represents two corresponding pieces of information. In this case, given a taxable income, it's the corresponding tax due. Okay, how about the left-hand graph? Brianna, here.
It's just the taxable income, or when they've made whatever that is, like $8,000 or whatever, that's the marginal tax rate. So it's just like the pair together.
Right, two pieces of information. At this particular taxable income, you've got a certain marginal tax rate that you're paying for that $1, right? For that $1. Okay? Why does the marginal tax rate versus taxable income jump discontinuously? So the left-hand graph, why does it jump discontinuously? Christopher?
Well, because if you, from the piecewise function, we showed that that up to a certain point when she made a certain amount, she would be charged that certain rate, but then at the very next dollar,
right,
it would jump up to that next amount, and then it would stay at that same constant amount up until it got to a certain point, and then the very next dollar jumps up again.
Right, so this is how they've defined our tax rate, that we're gonna up to a certain amount of money, exactly what he said. Up to a certain amount of money, we're gonna pay a rate, and then for the next penny, suddenly we're paying a higher rate. And then we're gonna pay that rate for a while. And then there's gonna be a point where it's gonna jump. So exactly what he said. Okay? So why does the graph of tax due versus taxable income change slope abruptly? Alana. So can you see that, first of all? It's kind of a little bit tough to see, but for instance, it changes slope abruptly right about there. And then again right about there. So why are there abrupt changes in slope?
Because the rate is changing, so
And how does the rate change? Gradually?
it's not proportional. It's changing.
How does the rate change? Amanda?
Because it changes so suddenly, it just does that jump. Then the piecewise, like where it goes to that moment, then all of a sudden the slope has to change suddenly, which causes that kind of drag.
Yes. And how do we see tax rate over here? How is tax rate represented in this graph over here? Crystal?
By like the slope of the line.
Slope of the line. So if the tax rate jumps here, then over there, slope is going to change abruptly. Okay, in what way does Sarah's tax due accumulate? And how is this reflected in the graphs? So in what way does her tax due accumulate? Joel, give it a shot.
The tax due still keeps a record of all previous tax rates.
Okay.
But those cause that Sarah to owe.
Okay. Alexis.
Because as you keep going along her taxable income, it keeps going up. It doesn't like stop back at zero every time.
Okay.
Like is connected the whole way.
Good. What else? So, when it's snowing, those of you who have experienced gotten out of central Arizona and seen snow, okay, this is probably most of us, but so when it snows, so like, does it start to snow and then you close your eyes and you open your eyes and then there's a foot of snow? And then you close your eyes and open your eyes and there's 2 feet of snow?
Oh my god.
No. So
No.
how does, for instance, snow, how does it accumulate?
Gradually.
Yeah, so it
It builds.
Constant rate.
It-
Or, well, at a rate.
so the idea is that it will accumulate a little bit at a time. Bit by bit by bit. Okay? Bit by bit. So how can we see Sarah's tax due accumulating a little bit at a time in that graph over there? How can you represent that her taxes are growing a little bit at a time?
Is it, because it's a continuous line,
Okay? Because it's a continuous line.
so it's going a little bit, so it's tracking each point, the little bit that it moves. every
Okay, so yeah.
Exactly what she said, but a continuous increasing line.
Okay. So we can think of accumulation as decrease also. So we just get like as a generic term. So we can think of it as decrease. Alexis.
I was just gonna say you can track it by the line that's drawn from the x-axis to that point, that line is growing gradually.
So how can we represent Jason?
Well, the way I'm looking at it is, yeah, each little chunk has a different slope,
Okay.
but it's not jumping drastically.
Okay.
So, I mean, if from the first one to the second chunk it was almost vertical, then there's going to be a lot of change within that. So because they all have around the same slope,
Okay.
that's how you can kind of show that it is gradually building up on each other instead of just jumping up to that higher tax due.
So say here we are at $20,000 of taxable income. How can we think of, from there, the amount of tax due accumulating? Michael?
Well, whenever the slope changes, you're gonna like hold on to that amount, right?
Okay.
And add whatever. So like when the slope changes, you're gonna have the whatever tax due at that point.
Okay.
You're gonna hang on to that amount, and then at the purple point or whatever, you'll add however much tax due you have there to the amount you have in the slope change.
So you're going to add $1,000 of tax? 5,000? How is it going to accumulate? Say starting at the taxable income of 20,000. Well, what will happen next? You're going to earn what? You're going to earn a little bit more money after $20,000, right? Maybe $1 more, maybe 50 cents more. How can we represent that? If the taxable income is X, how can we represent earning, say, 50%, 50 cents more, 50 cents more? Yeah, it's like delta X, right? So how does the tax due accumulate then? What happens when you earn 50 cents more? Or you
at the rate of that interval.
Yeah.
It is a scalar of the rate of that interval.
You're going to have a little bit of tax owed on that increase in taxable income,
At the rate of that interval.
depending on the rate. Okay? And so every time you earn 50 cents, what happens to your tax? It goes up. A lot or little? A little. Okay, it's the idea of accumulation. That as your taxable income increases in little bits, then your tax due will increase in little bits throughout the year. And that's can be represented, say, by delta y's for small delta x's. Okay, here's another function. Okay, so over on the right, that's a basketball. It's rocket powered. Okay? So this scale over here is feet per second, and this is number of seconds, and then this is showing feet from the ground of the basketball simultaneously with how this graph is being swept out. So what I want you to do is just take a minute to make sense of what you're seeing. So what is it? What are you looking at? Make sense of this graph that you're seeing. So I'll just tell you the units. This is feet per second on this scale. This is seconds. And this is actually tracking the physical height of the ball. Okay, go. So make sense of what you're seeing. What are you seeing here? Talk to the person next to you.
One, I would say, realistic motion would be right. So if we had this rocket powered basket and had like a stopwatch and measured the distance of travel in those intervals and then tried to estimate that using a piecewise linear function, that would be
It's almost a constant acceleration, but why usually the word constant acceleration.
So are you saying like
it's speeding up?
Right.
It's accelerating.
Yeah, the one on the left, I mean, represents the rate, the feet per second, and then for every number of seconds. So it's like, so you're saying that the rate, like in feet per second, is increasing all the time.
Yeah. The rate is increasing or decreasing, just changing. Like changing in general.
depends which one you're looking at. Are you looking at the rock? Are you looking at the rocket?
Yeah. Sure.
Yes, that's the rate.
Screen captures of the animation.
Yeah, so they're animations. Yeah, pasted into a PowerPoint file.
So you would just do the
No, it's just
3% of you do the animation, or is it something that you just grab?
So I actually didn't create this, so I'm not sure the details about it, but I think he just had a movie,
And then feet per second is
and then you just put the movie into the file, and it just plays it continually. And it also gives you a bar, yeah. Okay. So what are we looking at here? So James.
Rocket powered basketball is accelerating.
Okay. So it says accelerating. So it's
Acceleration is discontinuous, so it's accelerating at a certain rate for a given amount of time.
Okay.
I don't know.
okay. So the basketball is speeding up. Okay, how is it speeding up? So can anyone take that and run with it? How is the basketball speeding up specifically? Mario.
Every half second, the speed is increasing by a foot per second.
Okay. So every half second is increasing by a foot per second. Say more? Somebody else. Steady, gradual increase every half second of a foot per second. Is that what's going on here? What's happening to the speed between 0.5 and 1 seconds?
That's what I thought.
Speeding up? Between 0.5 and 1 second. Is the ball speeding up?
No.
It has a what?
Constant rate.
It's a constant rate. So it has a constant rate. How is the ball speeding up? Sure.
We are talking about when we established that every second it increases by 1 foot per second. So as you get longer in the process, it's exponential. It looks exponentially, even though it's going to be a piecewise function. It looks exponentially increasing in speed to where it covers more feet the longer. For every unit, for every second, it covers more feet per second for the longer you go throughout the graph.
Okay, you're still not getting the kind of the key element here to how it's speeding up. How is it speeding up? Because everything you said just there could be true about it gradually speeding up. So is it gradually speeding up? It's not. So how is it speeding up? Andrea, is that almost a hand? No. Yeah, Ashley.
Well, it's increasing more and more every half a second, like the rate at which the ball is accelerating.
Okay.
Is increasing more and more after every half second.
Every half second it increases speed, so if you were to do this in the position time graph, you'd have...
Just talk about what's the speed doing? What is the speed doing? So to say every half second it's increasing by 1 foot per second does not get it's true, does not get the nature of how the speed is increasing.
So for every half second, its speed is constant, and then at the next half second, it increases for a foot, and then it's constant for a half second, and it increases.
That's right. So the changes in speed are changes in speed. Abrupt. It suddenly changes speed. So it's going at a constant speed, then suddenly it jumps up to a faster speed. And then the next half second it goes for a constant speed, and then suddenly jumps up to a faster speed.
Okay.
Okay? So where should you look to see elapsed time growing? Let's rapid fire here. Where should you look to see elapsed time growing? Crystal?
Like the x-axis of the left.
The x-axis of the left graph, right. Where in this animation should you look to see the basketball's velocity for the current value of elapsed time? Sarah?
Y-axis.
Of?
The left graph.
The y-axis of the left graph is giving us the velocity at the current value. Okay? Where should you look to see the basketball's height for the current value of elapsed time? Richard?
You're going to look at the y-axis on the right graph.
The y-axis on the right graph, that's right. Okay, what does the current value of the basketball's height mean if that amount continually changes? So is height continually changing? Is that true? So what does the current value of the height mean?
Does that mean like you need to stop at a certain
Yeah, so we'd have to kind of pause time. If we pause time, then we'd have a certain value, and then if a little time went by, that current value would change to a new value. What does a point on the left-hand graph represent?
depending on what time has elapsed, is how fast the ball's moving.
Okay, it's a combination. So this point right here represents that at that time, we have that certain speed. Why does the graph of the basketball's velocity versus elapsed time jump discontinuously? Why does it jump discontinuously? Ashley?
Like it's never moving at a speed between 1 and 2 feet per second.
Okay.
It's just moving at 1 feet per second, or 2 feet per second, or 3 feet per second.
Right, so there needs to be this jump from one speed to the next. And so, realistic situation? No, but actually, bombs in World War II, the German bombs in World War II were called buzz bombs, and they kind of had this kind of velocity profile because they were like had rocket boosters, and every time the rocket would fire, it would kind of jolt up to a faster speed, and then the next rocket would fire and would jolt up. So, yeah, so this is not realistic, but it kind of is like the German bombs. Okay? In what way, last question, in what way does the basketball's height accumulate, and how is it reflected in the graph? Last question. How does the height accumulate? Anyone pick up on what this is about? Alexis? It keeps getting higher a little bit at a time. These dots that it's leaving behind, are per half second. So if we looked at little bits of time of a half second,
As it accumulates, each half second, it has gone further than a half second before.
so for every little change in time, the height, we get a little increase in height. And so that's how height accumulates, a little bit at a time, just like you said. Okay, so you can keep working on your bowling balls.
I sent out already. I emailed you already, but I sent my falling balls this morning before you sent out the email.
Okay.
So I just sent it as a response to the homework 7 email. Do you want me to send it again?
Are you done? Is that?
No, it's not done. Should I just?